Again, welcome. Okay, so we have concluded the unsupervised machine learning, and we are starting the last phase of this program. So we want to look at general introduction to supervised learning. Because machine learning is divided into two, let's say, two methods. We have the unsupervised, then we have the supervised. From everything we took our time to understand under that unsupervised, we realized that it's an aspect of machine learning or data science that focus on data preparation, standardizing the data, making sure that your data is perfect or is suitable to be injected into the predictive model. So with that assumption that now we have all the necessary skills, all the techniques, the algorithm involved in perfecting, organizing our data in such a way that it can be given to a predictive model. So we'll look at the supervised aspect. So I'm going to start with the definition. What is supervised machine learning? What is supervised machine learning? But I decided to go back a little. So that we can pick it up from somewhere. So at first, I'm looking at what is machine learning itself, which we have already explained in our previous lectures. I will define machine learning as a field of AI that enables computer to learn patterns. So the key word here is pattern from data and make predictions, decisions without being explicitly programmed. So which means that the focus of machine learning, or one of the characteristics of this field, machine learning, is actually targeting or training the machine to understand data so that the machine itself can as well use the data for prediction or making decision instead of the traditional method, which usually involve human calculation. The research has shown that it's more accurate. That is the reason why you see that the markets in the field of data science has shifted to data scientists instead of just data analysts. Now, the analogy here is that think of it as teaching a child with examples. That is exactly what we are trying to illustrate, teaching a child with examples instead of coding rules. We give the computer data and let it find the rules. So you can see the difference. So I repeated this definition because there are some key terms that I want us to understand here. So that is wrapped in what I just explained. So let's quickly talk about briefly types of machine learning. So there are three main categories, but that's if in the aspect that concerns us as data scientists, we focus on the two. So the first one is supervised learning. And what does supervised learning entails? The machine learns from labeled data, which means input plus output provided. That is what we can refer to as labeled data. Example, predicting house price. So it's about, this aspect is about predicting. So we're done with the aspect of cleaning, restructuring our data. So what we are focusing on in this section is predicting. And when I started this training, I told us that if we are to allocate the time, 80% is allocated to which of the aspects of machine learning? 80% is unsupervised. So that is to tell us that we are not meant to spend time here because we have learned all those techniques on how to standardize our data. So any of those data that we have standardized, we can just call it off and look at some key variable due to the prediction model or prediction you want to perform. So example, predicting house prices, which means that we have to impute the size of the house for you to be able to predict. You need to impute the size, the location, the rooms, and then the output, the price. So we must have an input. We must have a sample that we train. But it is that trained copy that we now use, the machine uses for the prediction. So let's look at some of the subtypes. Under the supervised learning, we have two main branches, which our focus is going to actually be. We are going to focus on regression. So you can't talk about supervised learning without looking at regression and classification. So this will form the major focus of this training. Now, what is regression? Regression means predicts continuous value like price, salaries, while classification means predicting categories like spam, not spam. So just giving an example, but as we proceed, as we take them one after the other, we are going to understand. Although during the general introduction to this field, I have explained what we mean by classified data and regression, but we are just capturing them again so that we can just refresh our memory. Now, I don't want to take our time talking about unsupervised, though we have already concluded that, just to read through since we are writing. So the machine learns from unlabeled data. So one of the direct way of differentiating supervised from unsupervised from this particular slide now will be what? Just keyword you can use. One is what? Label. While the other one is what? Unlabeled. So we can summarize label as what? Organized data, structured data. Are you following? Why the unlabeled can be what? Unstructured. That is the reason why we spend time to structure, because we assume then that we are given unstructured what? Data. Data that cannot be passed into analysis or prediction model. Now, we have another aspect. So, for example, here, talk about only inputs, no output. So you can see that is another core way of differentiating them. But in the case of supervised, we have what? Input, and then we have what? Output. So that is why prediction is coming here. So what you give is what the machine uses to what? To predict. That is why we are getting the output under supervised. But then we're just giving, we're just segmenting, we're just after grouping That was the major focus. That's why we were talking about clustering and the rest of them. Now, we also have another branch of machine learning, because sometimes this machine learning as a program is not just for data analysis. You see, we can see that the third one talk about what? Reinforcement what? Learning. So this is an aspect some persons can focus on, which deal with what? Look at it now. The machine learns by what? All of them are AI. All of them, they are field derived from what? The AI. All of them. But what we are talking about is that this third one, we are not going there. It's not what we are looking at. But let's look at, I just brought it so that we know that there's another aspect of it that one can venture into. So the machine learns by what? Interacting with an environment and receiving what? Reward, penalty. That is game. Indirectly, that is game building. People that develop these games. So that is an aspect of the machine learning. So let's quickly explain some of the key concepts. You see, as we continue, we're using some terms. So when you are learning supervised, there are some key terms we need to understand. There are key terms we need to understand. Amen. Right. So let's look at these key concepts. So anybody practicing this field, he or she is expected to be familiar with these terms. Number one is features. I don't think there's anybody here that do not understand features. We have already clarified it under unsupervised, right? What are features? The headers, good. So we need to understand that. So these features, they are usually referred to as what? The independent what? Variables. Or what? Input what? Data. Like what? Age, income. So we need to understand that. So that is why it's good you graduate from unsupervised, because there are a lot of things here. That is why the speed will be fast and there are not going to be much explanation. But if, for example, this is the first phase you happen to come into, we have to start breaking some of these things down. So label Y is called what? The target what? Variable, which can also be referred to as the output we want to what? Predict. Because here we are going to focus on training what? Data. So before you train data, you must have a sample. Are you with me? You must have a sample. And then That means what we are going to have, the sample can be the S. The train can be the what? The Y. Then before you can, because there must be input and what? Output when you are training, like we just established. So that is why we want to understand what this term means. Now, what is a model? What is a model? A model is what? Mathematical function, mapping what? The input from the input what? To what? To the output. So when we say machine learning is about what? Building what? Model that can predict data. It means you are building mathematical what? Functions that can be given a data set and perform what? Prediction for you. Now, training, teaching the model with data. That is what the word training in this context means. That is what? Adjusting internal what? Parameters. What is the meaning of prediction? Using the trained model on new what? On new unseen data. So, number 4, we will try to compare what? Regression versus what? Classification. Regression versus classification. Regression versus classification. So regression means predicts continuous value in a simple term, continuous value. So now I want us to ponder and look at something here. So for instance, you develop a model, or let's say you are analyzing a data set that is still ongoing. That's a perfect example I can use. Like, okay, let's say a company gives you their data storage, right? And you develop a model that will be analyzing their data, let's say February, March, April, down to December. Then when they get to December, they close the data entry, and then they open another entry the following year, right? Now, at January, let's say February, that database you're analyzing, is a continuous database or classified? So I just want us to understand what this regression and what classification is talking about. If I give you a data set that we have concluded the activities, no more entry, where will you classify that data? Is it regression? Classification. Good. That means you are going to use classification model to predict such data. But if it's a data that they are still entry, that is what, as their entry is updating the model, then you have to adopt what? Regression. So that is why 2 of them are very important. We understand them. So, like I was explaining, classification predicts what? Categories, label. Example, predicting what? If an email. This is just a kind of example, just for us to have a kind of clear picture of what we are talking about. So, although it's not stick to this. So, number 5, real-life application or supervised learning. Real-life application. Real life. Where do you think that this particular supervised learning skills or the model you must have developed, where are they being applied in real life? Finance. I don't know if any of us understand how all these bank, when they want to loan money, those apps, right? Once they give you the money, if you apply for this mobile loan, nobody is there to calculate when the money is due. They have already trained the model, right? Yeah. To do all the calculation, to know how much you are going to be paid, maybe per cycle, whatever it is. You just see that the model keep updating. Somebody have sat down to develop that model, which sometimes has been repackaged as what? An application. That once you install it, it analyzes. Loan approval, fraud detection. These are models. So this is actually an aspect that is very deep on its own. You can specialize in building or customizing model for company based on their what? Peculiar what? Activities. So you can take it further than just, learning. You can go to the extent of researching how to build different model based on what a company tells you, okay, this is our business system, this is how we operate. Then you be able to what? Develop a model. Healthcare, disease diagnosis, predicting what? Patient what? Risk. So what we are talking about, that's why you see that this data science is more lucrative, or let's say is more which word do I use? Is more practice in the health sector today. Because most our medical personnel now, they are not doing much work. So they have different models that predict once they collect the patient samples, they put the detail there. The model we automatically tell them the drugs and everything. So everything is now becoming automated. But somebody must have trained the model. And the good part of it is that if I train a model now to analyze a particular data, when I'm given another data, I don't need to train again. It's just for me to change the data name, throw that data inside, but then you must have ensured that that data has been standardized. You remove that. You must have engaged all your skills in unsupervised, to make sure that now you know that you are preparing this data to be passed into a predictive analysis model, which means you must have known what and what is required. Like when we were presenting the other time, I was so excited when people were using some core terms like identifier remover. That means you now understand that the model cannot accept such data. Your data must be numerical, because that is what the machine can actually use to predict. That is why at some point we have to start we have to standardize. Remember when we use standardize, meaning that we have different variables.
Yes.
And we have to classify all of them to, like, maybe male should be 1 and the female should be 2, because we are driving to somewhere, we know where we are going. That is the reason. But in the research, when they are collecting the data, they will collect everything like that. But it is you that will go and sit down and restructure it before you can pass it. E-commerce, product recommendation, customer churn prediction, business sales forecasting, demand prediction. So there are a lot of prediction, real life application of this. So having said all this, we can now go into regression. Introduction to regression. That is the first one I am focusing on first. Once we are done with regression, we can now focus on the classification. So we are not going to spend more time in this aspect. It is an aspect that once you understand how it works, you can continue to build different models for different companies. You research. And the good part of it is that once you have gone through the training, you don't even need to be writing this model code. ChatGPT can write them once you know what you want, the kind of model. Once you can describe your data, ChatGPT will give you the code just for you to manipulate. Yes, yes. No, you also go through the training and understand, so that when ChatGPT gives you we know what and what to change to suit the data you are given to analyze. So what is linear regression? So we want to focus on it, and we are going to work with a very simple data. So what is linear regression? Linear regression is one of the simplest and most popular algorithm in supervised learning. One of the simplest and most popular algorithm in supervised learning. So anybody learning this have to start from the regression. A type of machine learning where we train a model using label data. Now from the 10th, you now understand what we mean now. Label data. That's organized, structured data. So you don't involve this if your data is not organized or well structured. it helps us predict a continuous, which means what? Look at what I put in bracket there. Numeric. So you see the reason why we find what? Non-numeric. Try to remove all those things. Value based on one or more what? Input variable. So this is a very concise definition of regression. I've captured what and what is required.
So I'll give us some time. I want you to go to Excel and compute
these two columns. So we'll call them in our digital notebook just to use them to perform the predictive prediction model. Let's just compute it. And then once you are done, you send it on the group WhatsApp group so that I can also have a copy. Can be on the same page as we proceed. All right, so now that we have our data ready, let's so there is a background explanation that I want us to understand, just for you to have an idea of what's the model will be doing in order to predict. So this is just for theoretical purpose for us to understand, okay, if we are to do the manual calculation, because all these things that we are learning the computer version, before the introduction of this machine algorithm or model, there have been manual way of doing all these things that people study even down to university. We just that to involve a lot of calculation formula, but it's that same concept that has been compressed or developed into what the computer system. So in other words, instead of us going through understanding all the mathematical calculation that could have been going on or that will be going on in the background, we are using these functions in Python, and we don't even know what Python is doing at the background. So that is the essence of this. So if you look at this diagram, you can see that you pick the price. You pick the price. That is what 3,300, and you are trying to predict what it will be. Currently, for example, this is the price, and then the machine will predict that, okay, in the next 2 months, this is what it become. So now, what exactly the machine will have done to be able to predict, that is what I want to explain. Now look at this is expected to be a kind of manual calculation, which we are not going through or into because we are using AI functions. So what the machine will be doing is that the price, just like that's 3,300, the price, and you're trying to predict. So the machine is considering 3 parameters. The M is the what? The slope. Y, that's what is multiplying it by area, then plus B. But we need to know what is B and what is S and what is what? M. So this is just for knowledge base, just for you to understand what the model will be doing at the background. Now, if we move forward now and we get here, you will now see that the price is the what? The dependent what? Variable. While the area is the what? The independent what? Variable. Now, just to explain further, so now let's go into our notebook to see how the machine will employ this calculation and be able to predict our data for us. So we are going to import some library. Which of the library that is new to us here from unsupervised? We are not new to what? To pandas, right? We are not also new to what? NumPy. We are not also new to matplotlib. This one is for the graph, because at the end of the day, we are going to also use graph to present some value. Now, the main library that we are introducing here is which we also call some function from, even under unsupervised, is what? sklearn. But then the sub function we called from the sklearn is different from the one we are calling from. We are calling right now, right? Yeah. We have never called what? Linear what? Underscore what? Model. So this linear underscore model, it is a sub function under what? sklearn as a library, which is used for linear, which is a linear regression. So the first aspect of the regression now is linear regression. Now let's quickly create this. So let me switch to my notebook. If you can just snap it, because I also want to write and code along with you guys as well. Can I move? Yeah. Okay. So I need to also. So let me use comments to also explain linear regression. Import pandas as PD, import NumPy as NP, import matplotlib dot pyplot as PLT. We are used to some of this. Then from sklearn, import linear underscore model. Right, run my code. The one has imported, right? Yeah. So let me wait for mine to complete. Perfect. So, all right. So now the next step is for us to load in our data, the data we want to train for the prediction. Here, the DF is my data set, which could be any name as you want it. So let me go back to my notebook. Loading your data. So I'm representing my data with df equals to pd dot read underscore CSV, the name of my data, copy it from here, which is home, get the parts. As usual, I can use the relative method by just putting 2 dots. So I need to see my data, df. And then in case the data is so voluminous, maybe you want to see just the first 4, then that is when you will do dot what head. And then if you want to see more than the first 5, you can put the number inside. Okay. So now that we have our data ready, so the next step is now let's plot a scatter plot just to know the distribution of the data set. So all this is just for you to have a more view on what the data is. What is that? Eh? Oh, sorry. So let's quickly yes, percent. Yes. It should start with the matplots. Under Python documentation, it has its own function. Let me give us time. So, like I said, now let's plot a scatter plot. Just to know the distribution of my data points. Okay, so from pandas, from Python documentation, I bring in the matplots, which we have already discussed in the previous class. If you want to plot graph, this is the foundation of all the plotting function. Matplotlib, inline, plt dot slabel. So let's say, yes, you can put asterisk. Whatever sign you put in that mark is what you get. Area per square feet based on the data set. So PLT Y label should be price which should be in price should be USS dollar, Naira. PLT dot scatter plot DF as the name of my data dot the area, comma DF dot price. So we have to follow the case. Oh, that is what you did. Yeah. For your area, the way you type it in your data. Oh. Yes, I'm following it. So, color was to, let's say red, choose any color. Then the marker, let me also choose a asterisk. Asterisk should be better. Then to display the graph, PLT dot show. So let's see if I'm going to get error. So module this has no attribute what while label. Oh, there's a mistake in the spelling of my label here. And that is only, let me check again. Perfect. So you can see that we have straight line. So which means that, remember the topic is what? Linear what? Regression. So if the data point is not linear, then you can't use this method. Probably we'll consider the method in the next class. But today, just focus on introduction on how to use linear regression. So now that we have achieved that, so this is what's trying to capture. So now the next thing is this. So firstly, create a linear regression what? Objects. Then secondly, we are going to fit. Hope you can still remember that we are using this fit, which is one of the major functions we are using to transform our data under standardization. So that is what we are doing here. So the reg is the linear regression object. And then remember the model that we got from what? From sklearn. Remember, from sklearn, remember that we imported this. And then we are concatenating it with the linear regression function, which is coming from. So the main reason why we imported that function from the sklearn is for us to, I believe you can see it better now, is for us to be able to assess what? Linear what? Regression. This is the main function. So how can you interpret this? This function is directly under which container? This function that I'm highlighting at is directly under which container? Directly under which container? Good. So which means that if you have not imported this from sklearn, you cannot what? Which one? This one? No, when you are importing, you did not import this one now. This is what you import. So this one is not done. Exactly. That's what I'm asking. So that's the reason why, because you want to access this function. That is why you imported this from sklearn. And now we are saving the whole of this as linear regression objects as what? Reg. So as we proceed, anytime we call reg, it will invoke what? This function. And then whatever data we are passing into it. As you can see here now, this is a reg where we want to transform the data. So we pass the data into what? We concatenate the transformation function with the linear regression object, and then we now supply our data and then supply the variables and then we got the calculation. Then here, this is where you are now using the predict function. So once you run this, then you should be able to know the value within that your price column. So in your own case, you can choose another price that you want to predict from the column of price. So once you put any price inside and you run this, it will predict it for you. Let me allow us to apply for so let me see if we can be on the same page. So like I said, firstly, create a linear regression objects. Then secondly, fits. This is just like summarizing the steps you have to go through. The data. So the word fits data means to train, or which means meaning you are training the linear model. So I would say the linear regression object is equals to the linear underscore model dot, this is case sensitive, linear regression function. So let me confirm that. Okay. So since we have created an object, now let's use the object to fit the data. Fit, supply the parameter, the data set name, df, df, square bracket 2 times, area, the way it is in your data set, comma, the data set again, dot the price, right? So we have the data linear regression model trade. Now let's use predict with our price value. With price values. So we call the model, which is reg dot predict so which of the value? Do we have this value in the data? You have it, Abby? The same value. Okay, so let me use another value. It's not here. No, it's in between. It's in between this and this.
That's what the assignment was. Predict.
Yes, exactly. So since we confirmed this, let me predict with 3,600. 3,600. So once you run it, it's a linear object has no attributes. Predict. Okay, good. Okay, so are we getting the same value? Good. So we are not getting. So any value you use as the prediction. Now, I want to take us back to the slide. So the slide, I think it should be this. So the assignment here is, the assignment was, let me reduce the, given these home prices, find out prices of what home whose area is this square feet. And then you can also do the same for this. Let's predict, because the assignment is we should predict with this and this. So it is the data and what exactly you are asked to do that will determine your prediction.